Hi everyone, this is 5.8 Graphing Absolute Value Equations. And basically an absolute value equation looks like a V. You can think of V for value. This is called the parent function. This is the basic absolute value function. And you'll see that with this basic absolute value function, your vertex is always going to be at 0, 0. So if I plug in a 0 for x, the absolute value of 0, 0. So here's my vertex. And I can plug in other points that come before and after the vertex to be able to make my V. And if you notice, on each side of the arm, the slope will be the same. So from this here, my slope is up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Same thing here, up 1 over 1, up 1 over 1. So my slope is 1, except for, in this case, I know it goes up because then there's no number in front of the absolute value, or actually there's a 1, and that number is a positive 1. So therefore, I know it points upwards, or it can also point downwards. Now, the equations for absolute value are going to get more complicated. So notice here we added a number on the outside. So what does that number on the outside do? Well, we know this here is our parent function, which we just had in the last slide. So I know this was 0, 0, and it was negative 1, 1, 1, 1, negative 2, 2, 2, 2. Notice because it's symmetrical that it's always going to be the same number on both sides. So here's my V, my parent graph. Now here I put a plus 2 on the outside. I added this one, which is called your K. So let's see what happens when I add a K. Well, if I plug in 0, now I have absolute value of 0 plus 2, which is 2. If I plug in a negative 1, now I have absolute value of 1 plus 2, which is 3. Which means if I plug in 1, absolute value of 1 is also 1. 1 plus 2 is 3. Remember, they're symmetrical, so these should match. And if I plug in a negative 2, absolute value of negative 2 is 2 plus 2 is 4. And these will match. So I'm going to graph this. So 0, up 2, negative 1, 3, positive 1, 3, negative 2, 4, positive 2, 4. So there's my absolute value graph for that equation. Now let's do the last equation, where I added in a minus 2. So I'm going to plug in my vertex, 0. 0 minus 2 is negative 2. I'm going to plug in my negative 1. Absolute value of negative 1 is 1. 1 minus 2 is negative 1. And I'm going to plug in my negative 2. Absolute value of negative 2 is 2. And 2 minus 2 is 0. So let's graph that. 0, negative 2. Negative 1, negative 1. Positive 1, negative 1. 2, 0. Negative 2, 0. So make a generalization about what adding or subtracting a number on the outside to the absolute value does to the parent graph. Well, we can see that adding a number on the outside or subtracting a number on the outside shifts the parent graph up if we add the number, or down if we subtract a number. So that is what the number on the outside does. It shifts the parent graph up or down. Let's look at what happens if you have a number on the inside of the absolute value. So again, here's your parent graph. We know our vertex was 0, 0. It was negative 1, 1, 1, 1, negative 2, 2, 2, 2. So we graph that. And then I want you to take a second, pause the video, and fill in the other two charts, graph it, and you decide what it is that h, the number inside of the absolute value, does to the graph. How does it shift the graph? Okay, so we're back with the answer to this one. And here, if we plugged in a -4, I get -4 plus 2, which is -2, and the absolute value of -2 is +2. -3 plus 2 is -1. The absolute value of -1 is +1. -2 plus 2 is 0. Absolute value of 0 is 0, and so on. Right? These are symmetrical, so they're going to match. So here's my first graph. My second graph is the blue. And notice that when you add a number on the inside, the h, that shifts the graph horizontally. So now we know that it did a horizontal translation. So think of h for horizontal, whereas the k, the last one, was your vertical translation. Okay, so this one is looking at what happens if you put a number in front of the absolute value, so being multiplied to the absolute value. Well, we don't have our parent graph here, but I'm going to draw it in for you. So again, our parent graph. And I want you to take a second and fill in these 4 charts. These 2 on the bottom actually keep going to have a 1 and a 2 afterwards. You just can't see it because it's cut off. I can bring it down a little bit. And then I want you to determine what it is that the number being multiplied to the absolute value on the outside does to change the parent graph. What kinds of translations does it do? Take a second, make sure you pause the video. Okay, we're back with the answer. So if you look at the first graph, which is the one in red, we added a whole number in front and it was a negative. So the negative makes it point down, and since it is a whole number, a number above 1, it's going to also make the graph more narrow. Over here, it's a negative, so it points down, and it's a fraction, it's less than 1, so therefore it makes the graph more wide. So what we can determine is if it's a negative, it goes down, if it's a positive, it goes up, and if the number is smaller than 1, it's going to make it more wide, and if the number is greater than 1, it's going to make it more narrow. Alright, so these transformations can all be combined. Here is my a that was the number on the outside, which made it more narrow or more wide. And if it was a negative, it went down, positive, it went up. Here is my h, which shifted it horizontally. And here is my k, which shifted it vertically. So notice how this graph, the red one, is this equation that is here. And the vertex of this graph is 1, 2, 3, 4, 4, comma, 1, 2, 3, 4, comma, 3. Because the vertex is always h and k. So my h is not -4. My h is actually 4 because the equation is x plus h. So the equation is y equals a times x plus h. So therefore, since it is negative here, I'm sorry, it's x minus h. I messed up there. It's x minus h. So therefore, since it's already negative here, that means that what I plugged in was a positive 4, otherwise it would have become a plus. So my vertex is always h and k, which means it's going to be the opposite of the number in here, positive 4, and this same number on the outside, 3. So the opposite of what's inside and the number on the outside stays the same. That is your vertex. And then it would be very easy to graph because all you have to do is take the number in front, the a, and use that as your slope on each arm. So it's 2, which is the same as 2 over 1. So I go up 2 over 1. Up 2 over 1, and do the same thing on the other side. Up 2 over 1, up 2 over 1, and it's a positive 2, so I'm going up. So that is how you graph it using all the transformations together. This is a little cheat sheet that shows you all of the transformations the whole graph put together, the equation which is here, y equals a times the absolute value of x minus h plus k. Remember, your h moves it left to right, your k moves it up and down, and your a moves it, makes it more narrow or more wide, and it also opens up or down. These are all called translations. So when you have something that opens down rather than up, it's called a reflection. It's a special name for that translation. When you have something that moves left to right, it's called a horizontal shift. And when you have something that moves up and down, it's called a vertical shift. So that's how we're going to name our translations. So remember, graph has a vertex that is h and k, which is the opposite of the number inside the absolute value, and the same as the number on the outside. Okay, so let's bring it all together. I'm going to graph this one. I'll graph this one. I'm going to change the 0.5 to 1/2 because I think it's easier to look at a slope as 1 over 2. So my h and k, here's my h, here's my k. So my vertex is going to be the opposite of h, positive 2, and the same k, negative 3. So I go over 2, down 3, there's my vertex. This opens up because it's positive, and my slope is 1/2, 0.5, so 1 over 2. So I'm going to go up 1 over 2, up 1 over 2, and then I'm going to go the same way on the other side. Up 1 over 2, up 1 over 2. If I remember this, I don't have to use a t-chart. I can just use the slope and the vertex to graph it. You try doing this one over here. Make sure you pause the video so that you have time to do it before the answer comes up. Okay, so here's your answer. Your vertex is the opposite of this number, so negative 2, same as this number, comma 3. There's my vertex. It opens down because it's a negative, and my slope is a number in front. Since there is nothing, it's automatically a 1, so negative 1 over 1. From the vertex, I go down 1 over 1, down 1 over 1, and then same to the other side, down 1 over 1, down 1 over 1. And there is my graph. Okay, this is writing an equation from the graph that's there. So if we look at the graph, what do we need to know? Well, our equation is y equals a, I hate when this thing does that, absolute value x minus h plus k. So I know already the h and the k are going to be my vertex. So it's y equals a, absolute value x minus h, which is 0, plus k, which is negative 3. I don't need to put the minus 0, but I do need to fill in the slope. So let's see, from here to the next point, I go up 1, 2, 3, 4 over 2. So it's positive because it's pointing up. 4 over 2, which is the same as 2 over 1, or 2. So this is my a. So now I have y equals 2, absolute value, x minus 0, which is just x, so I don't have to put the minus 0, minus 3. And there is my equation for the absolute value. So very simple to go backwards once you know what all the numbers stand for. Okay, so that is all of 5.8. Tomorrow you will be practicing doing some graphs. You can choose to do a t-chart, but it's probably easier if you can remember how to do it using the slope. And good luck. Have a good night.